So hi, morning everyone. I'm Wenrui, a PhD student from Shandong University. I'm glad to be here to share our work on Android security with you. It's joint work with Alibaba and the Chinese University of Hong Kong. The topic is loss in conversion, exploit data structure conversion with attribute loss to break Android systems. Okay, let's start. On Android, every app must have a manifest file. It describes the essential configurations of an app, like the requested permissions and the content components. These configurations are highly relevant to multiple Android critical mechanisms, such as permission and inter-component communication. A manifest file has various elements, and an element contains multiple attributes. Here declares an activity through the activity element, and the name attribute can be treated as its identifier. So previous research has demonstrated that app developers may misconfigure their app's manifest files. Such misconfigurations may put their apps at risk. These studies give us a clue to consider the manifest security impact on the OS level. Also, manifest files bridge Android apps and the system. The vulnerable manifest processing procedures may be exploited to break the Android systems. So in this work, we systematically analyzed the Android manifest processing procedures and discovered a new class of vulnerabilities. First, let's take a look at the manifest processing procedures. During the app installation, the person package utils module, that is a PPU module, extracts the manifest file from the installed package and processes each declared element to construct its package settings. After that, other system modules will further process this data and update the corresponding system configurations. Take the activity element as an example. The PPU module first processes it and stores the first data in the activities field, and then this data will be converted into the system's activity restriction information. Next is our threat model. We adopt a common threat model. The attacker builds a malicious app with a crafted manifest file and releases it on various app markets. The victim user may install this app on her phone, and when the app is running, it can exploit our discovered system vulnerabilities to conduct malicious actions. Our investigation shows that the security of manifests may affect the OS level. Here we give a concrete case. As we will know on Android, the sensitive resources are protected by permissions. Permissions are defined by system or third-party apps through the permission elements, called system permissions and custom permissions respectively. They are three basic protection levels of a permission: normal, signature, and dangerous. For the dangerous permissions, they are granted by users at a runtime. So when an app requests a dangerous permission like the Kehuan permission, the system will show this permission dialog to make users allow or deny this permission granting request. Besides, if an app wants to use a permission, it should request it through the uses permission element. As an attacker, we build this manifest file, which declares twin custom permissions with the same name but different protection levels and groups. Also, it requests this custom permission and the Kehuan permission. And once a victim user installs this app on her phone running Android 11, this app can instantly get a Kehuan permission without user consent. Let's see the attack demo. We installed the app test. It's apparently harmless. Okay, we check its permission granting list. We can see that it has got the Kehuan permission directly. Then request this permission dynamically. Low permission dialog is shown, so the app test achieves permission escalation. This case has been confirmed by the Google and rated as high severity. A CVE ID was assigned. We further explored the cause behind this case. During the app installation, the PPU module processes each permission element and stores the first data in the list. Since the list supports duplicate objects, the twin permission declarations correspond to twin instances in this list. After that, based on this list, the Permission Manager Service module will further update an array map. And since the key of the array map is unique, the twin instances in the list will be converted into one item. And during this process, the permission level attributes are lost, causing inconsistent permission protection levels. So exploiting such an inconsistency, the malicious app can get the confirm permission automatically. Due to the time limitation, I cannot give more details here. You can read our paper for the complete analysis. So based on the design of the Android OS, we found that the root cause behind the evil twins flaw is a new category of vulnerabilities called the evil twins flaw. To generalize, when the system processes twin manifest elements, the defective data structure conversion merges them into one item without considering the duplication issue. As a result, the important attributes are lost, causing system configuration inconsistency. Given the significance and the complexity of Android manifest processing procedures, we believe that this case is just a tip of the iceberg. So to automatically detect the evil twins flaw-related vulnerabilities, we developed a data flow analysis tool, TwinDroid. Its high-level idea is to analyze manifest processing procedure implementations and identify the data structure conversion with attribute loss. So due to the limitation of the static analysis, the output of TwinDroid is a candidate set of suspicious methods. We need to manually confirm vulnerabilities based on the obtained method information and the Android source code. On a high level, TwinDroid contains two stages. In stage 1, it finds the package settings supporting duplicate elements. And in stage 2, it identifies the methods that access the target package settings and cause attribute loss due to data structure conversion. Finally, TwinDroid will output these methods names, associated element types, and saved data structures. We implemented TwinDroid and to facilitate its analysis and to improve its efficiency and accuracy, we integrated Suite and adopted several optimization approaches. Then we deployed it on this powerful server. In evaluation, we extracted the DEX files under the system/framework directory from Android 11 and 12 images for analysis. Finally, TwinDroid output 47 suspicious methods, and among them, we identified 4 exploitable inconsistencies, like these listing issues. 3 of the vulnerabilities can cause permission escalation, that is, obtaining dangerous system permissions without user consent, and 1 can cause permission revoking prevention. We reported these vulnerabilities to Google, and all of them were confirmed. 3 CVE IDs were assigned. Besides, since these vulnerabilities exist in AOSP, all the downstream phone vendors will be affected. Exploiting the evil twins flaw, a crafted manifest file can cause severe implications. So to eliminate it for Google and the OEMs, when they design or customize an Android custom permission, Android OS, they should avoid the potential information loss during processing configuration data. And for the app developers, they should avoid defining multiple elements with the same name, even for the different element types. In the end, let's summarize our work. We systematically studied the Android manifest processing procedures and discovered the evil twins flaw. If exploiting this flaw, a malicious app can achieve permission escalation. To detect this flaw, we deployed an automated tool, TwinDroid, and identified 4 severe vulnerabilities in the real-world evaluation. If you are interested in our work, welcome to read our paper and visit these 2 links for more details. That's it. Thanks.